Then before we start, I once again like to thank our sponsors, and let's move on to the first presentation. So this is from Markus Fischer, who is going to give a keynote, and Markus is a steering committee chair of ITRPV. Markus will provide the overview of latest technology trends in PV, which is extracted from the 16th edition of ITRPV. Markus will emphasize a bit on equipment wing of PV. Markus, the floor is yours.
Working, and so I will share my screen. Okay. So can you see my screen? Okay, great.
Good.
Thank you very much for this introduction. So I will report on the current findings of the 16th edition of the ITRPV, and especially focus on a little bit on the equipment that is here also discussed in the ITRPV. So outline is I will start with the status on PV learning curve and ITRPV organization. Then I will comment on the results and then give a brief outlook and summary. So the 16th edition was issued based on the contribution of about 50 contributors from Asia and Europe and US. So we have this well-known structure here to cover the value chain, and the preparation of the 17th edition just started, and I invite also you to contribute, and this would be highly appreciated. So now let's start here with the learning curve. So the summary is here, the price learning of the modules that are shipped. And based on the shipments of last year, we calculated here about 700 gigawatts modules shipped as a tremendous low price of $8 per watt peak. And expectation is for this year that these numbers will be even from shipment point of view larger. So we expect 750 gigawatts, and the price is expected to stabilize. So installation, in contrast, is a little bit lower. Nevertheless, it is a huge number of material in the market, and the tremendous price drop. So it was in the past here also visible in the learning curve. So we had several phases of price reductions, and afterwards the price recovered a bit. And so we expect this as well. So, but nevertheless, despite the price stabilization and the huge overcapacity, so it is a big challenge to continue the development. And so we will see what is the expectation here to maintain this learning rate of about 25% also for the next years. So what was the scheme for calculating the price here? The shift from the material point of view in the crystalline silicon-based PV was from multicrystalline to mono, and now from P-type mono to N-type. N-type is dominating, and we saw at the end of the last year no big differences between N-type and P-type prices, and the very interesting point regarding the volumes shipped is that from the shipments, not everything went into installation of new capacity, but also a significant share of the shipped material went into repowering. And here, beside Thalheim in Sachsen-Anhalt, Germany, we have a power plant, and there we find quite excellent that the repowering occurs. So here, this part of the field was repowered and with much less modules than expected. So this does not increase the overall installed capacity. So This brief introduction leads me now to the trends. So as mentioned before, so N-type is now the mainstream material. Nevertheless, we still have some P-type material in the market. And so a very interesting trend that we found in the past is the trend of the wafer formats. And this is the thing that material suppliers and especially here the equipment suppliers have to take care on. So the trend from the smaller formats, M6 is now gone, nearly gone. So M10 and M10R so are still in the market, but the biggest share is with the large formats, G12R and G12. And this we expected to be dominant in the future. So and here the interesting thing is about the thickness of the material. And what we see here is that the thickness for PERC, for the P-type, is coming to an end. So 130 microns will be the end. But here for N-type, we see that the trend is going to 120 microns. So I saw the first G12 also with 110 microns in the market, but this is more or less important for today for the heterojunction. But for TOPCon, the dominating format in the market is a 130 micron. And this will contribute to a significant price reduction in the future. Nevertheless, the tool suppliers have to care on the thin wafers, so and the challenges that come with them. So now let's have a look on the cell products, and this is the most important trend we see in the market. That the TOPCon is now here the dominating technology in the market. So in 2025, PERC is expected here from the ITRPV point of view to have less than 20% market share. Maybe the changeover will go faster. And we see other N-type technologies as well. So heterojunction and XPC, so the back contact cells are coming more and more in the market. And so all these things are ready for bifacial. So this is very important to know. And what is important, so with this technology changeover, especially we have this huge overcapacity. New capacity is only possible by replacing existing capacity. And so for these technologies, the tools have to be ready and the tool and material suppliers have to support this transformation. So now to the details in the process that the ITRPV found. So regarding doping for TOPCon, we have this boron doping, and the trend to higher emitters, metal sheet resistance is now going on. So in the market, we have here about 180 microns. So there is only a small difference between homogeneous and selective emitter. But what we see is that here with new technologies, especially with this LECO, so that is now in the market with close to 100%. So we see that selective emitter is not so important anymore in the future, and homogeneous emitter will become the technology of choice with boron chloride, trichloride diffusion doping. So trends in bed chemistry. So we see that especially here regarding the edge isolation, we have a changeover from HFNO3 to here alkalic etching. So the phase out of HFNO3 is continuing. And regarding cleaning processes, we see that ozone-based cleaning is gaining more and more market share. Heterojunction still uses or currently uses also RCR cleaning, but ozone-based cleaning is a big market share also for heterojunction. So then we will also see here in the conference trends on and tools for the ALD ALD for aluminum oxide passivation, and here for PERC that is used for PERC and TOPCon. And we will see here, especially for the TOPCon technology, how is the amorphous silicon formed. And ITRPV sees that there is a share 50-50 so far, also for the future. But this will be interesting to see what tool concept will be the tool concept of the future. And there we will see some interesting presentations, I expect. So here coming to the tool, so this is also a parameter that is reported in the ITRPV. So the tool throughputs, what we see here regarding the throughput, so the wet bench tools are really leading here the crowd, but nevertheless here, so ALD for the future is expected to increase the throughput up to 18,000 wafers per hour. So this is tremendous increase, and yeah, so let's see how this will be realized, but this is required to also lower the production costs. And boron diffusion is currently at the lower end of the throughput, but is also expected to be improved. So very important and most costly material besides silicon on the cells and on the modules is the silver. And there we see this, the trend that silver consumption is reduced. So we have here in the ITRPV defined a kind of minimum requirements for the silver consumption per watt. And we have here the differences for the different technologies. So PERC is currently consuming less, or the most less amount of silver. But what we see here, so the minimum requirements of ITRPV are now even bet by here the current tier 1 suppliers. And the World Silver Survey found also that the overall silver consumption last year was about 6,000 tons. And this corresponds at the 703 gigawatt chip to about 9 milligrams per watt. And this is well below the minimum requirements and well on target. So that will ensure that we have for silver no shortage in the future. This is a very important message, and we have this discussion since some years. So will we run out of silver? So based on the technology development, and I expect here also from DCAM some interesting news about the silver consumption. So we are on a good way. And so reducing the silver consumption is also supported by the new technologies, so heterojunction and the new coming tandem technology. So will more and more use also copper with silver coating and maybe also pure copper. So this is expected for the future. So how to realize the silver consumption reduction? So this is mainly done by reducing the finger widths. This, really impressive new technologies for printing, and ultra fine line screen printing is also possible with down to 7 microns. So this will also be in line with roadmap requirements, and so this finger reduction goes in line in parallel with increasing the number of bus bars, and the trend to more than 18 bus bars and trend to bus bar less is going on. And regarding metallization and test, so we see here also the throughput outlook, and the 7,500 wafers per hour are standard today, and the expectation is that this will increase up to 13,000 wafers. So let's see how this will be realized. So efficiency trends. So with the upcoming improvements, so we expect that over the next years, so 26% in N-type TOPCon will be standard, and heterojunction will also come to this or will be in this region, and IBC is there as well. So a little bit more expensive so far, and so to go beyond the limitation of single junction, so we expect in the after 2026 the tandem with going with a potential above 32%. So now some highlights on module. So copper wires will stay here, the main interconnect material. And what is important here, the module technology can handle also the thin wafer, so this will be no problem at all for module technology. So module trends. So Shafran mentioned that there are big progress, that there is big progress and a lot of products in the market. So glass to glass is gaining more and more, especially also with TOPCon technology. Nevertheless, there are here with the materials also challenges for the encapsulation. And here I expect also in this presentation, in this conference here, some news about encapsulation materials and backsheet materials for the glass to foil. So here half cell is standard. So, and interesting is also here to even increase the efficiencies that we will see here edge passivation in the market for this cut cells. And module efficiencies are expected to go even in parallel with the increase of efficiency on the cells to above 26% with tandem, but here on a level of about 24% with mature single junction technologies. So now a brief outlook, a brief summary on the system trends. So you mentioned here, so there are first of all the mainstream applications. This is rooftop systems and power plants. So the share of rooftop systems is expected to stay constant over the next years. But here we see new applications coming up, especially agro PV, built-in PV, and floating. So LCOE. So the PV is really progressing quite fast, and we are really ahead of the former expectations of IEA. So even in regions with not so much insolation, so we can reach here below 5 cents per kilowatt hour LCOE. So, and this is really impressive, and the PV industry is part. And the tool suppliers are part of this success. So now I come to the outlook. So we saw in the learning here from the years 2006 to 2024 and accelerated learning. So up to 40%. So we will see if this can be continued, but we expect that what is for sure that the efficiency learning and the per piece learning will continue, and that we can really continue this learning also in the future. And so despite with the overcapacity, the PV industry and the PV suppliers and the tool suppliers have to handle this challenge. So the outlook for 2050, so this is the future where we look in the ITRPV since some years, is that in 2050 we will have 36 terawatt peak installed, and the roadmap to this is fulfilled so far. So we are well within the expected market size with the ship volume of last year, and the expectation is that we will, with the PV installations ahead of the IEA predictions, and so we are sure that PV industry can handle the current challenges, and ITRPV will contribute also in the future. And so I invite everybody to contribute to next year's edition. And thank you to all contributors so far, and thank you for your attention. So Shafran, now it's time for questions.
Yes, thanks, Markus. That was really very nice. So there are a few questions in the chat window. it would be great if you can answer them in the chat. But I have one question from my, from myself. In ITRPV, you have seen, you have shown that tandem is going to, may enter the commercial production in 2 years, right? So in commercial. So when tandem enters the commercial production, so is it going to match the reliability? So 25 or 30 years of power warranty, or is this number should go down?
Yeah, so the challenge for tandem is to meet the requirements of the current industry, and this is 25 years, at the minimum, and the trend is even going to 30 years. So for the power, for the yield warranty, and that's why. So market introduction is, I think, possible only with this high warranty, level. So, and expectation is that this will be now within the next years, the time for maturing also the tandem technology.
But I have one follow-up question. Even in ITRPV, you have also shown that there is one segment that is really growing is repowering. So do we need this 30 years warranty? Sometimes modules are even taken out before their life, not because they are defective, but in order to, if you have the connection that can take higher power, then people would like to replace it with the more efficient or high powered modules. So in this context, do you think as an industry, can we look for new norms, or anyone in the industry is trying towards that, because you are talking to these industry representatives so often. So is there any ideology? So why not keep it at 15 and then very high efficiency, very efficient utilization of the space, because space often is becoming very expensive. So any thoughts on that?
Yeah, so you refer, if I understand right, so for repowering, repowering with higher efficiency modules. So especially in the example I showed, you see that there is also not easy to use the existing installation completely for repowering. So there are limitations. So in this special case, so the grid connection was the limit. So, and because also repowering is first of all an investment. So you have to spend money. And that's why if in your calculations, so repowering should appear after 10 years, so then it's okay. So but for house owners, myself, I have also installed in the past 3 years some installation. So it is very expensive, and the payback time for the house is not within 10 years. So it has to last longer. So, and that's why there's always a trade-off between repowering and long-lasting modules, and especially for the high price area. So long last is priority, and that's why repowering will also be a market niche. So it will be a market, and regarding resource handling, so it is also important to use the existing installations as long as possible. But anyhow, so repowering is a business case. Sure.
I think this is a big topic to discuss. Okay, thanks, Markus. So I just want to quickly catch up your thoughts on that. So thanks a lot. Please stay back and answer the questions. And
welcome. I will go through the questions and check.
Thank you.